There is a moment, somewhere between midnight and 3 a.m., when your body is at its most vulnerable. Your eyes are closed, your muscles are paralyzed, your heart rate has dropped, your breathing has slowed to almost nothing. Your awareness of the world around you has essentially switched off, and somewhere out there, something is moving through the dark. It doesn't make a sound, it doesn't need to, it already knows where you are. It has been tracking your breathing, following your scent, reading the tiny changes in the air that tell it exactly how deeply you've gone under. Now it's close enough to touch you. So here's the question that has haunted wildlife researchers, sleep scientists, and evolutionary biologists for decades. What happens next? The answer is not what you expect. And buried inside that answer is one of the strangest secrets in the entire history of animal survival. A secret that explains why you are alive right now, sitting here, watching this video. But to understand it, we have to go back to the beginning. Sleep is objectively one of the most dangerous things any animal can do. Think about what sleep actually requires. You have to find a location, you have to stop moving, you have to lose consciousness, and you have to stay that way for hours, completely at the mercy of whatever decides to walk by. From a survival standpoint, this makes no sense. Every predator on Earth is nocturnal or crepuscular, most active at dawn and dusk. Darkness is when ambush predators hunt. It's when stalkers move. It's when the most efficient killing happens. And yet every animal on Earth sleeps. Every single one. They have no choice. The brain demands it. Cut off sleep long enough and the animal dies. Not from a predator, but from the sleep deprivation itself. Which means that for hundreds of millions of years, every creature that has ever lived has had to solve the same impossible problem. How do you stay alive while you're unconscious? The solutions that evolved are extraordinary. Some animals solve the problem by never fully switching off. Dolphins sleep with only half of their brain at a time. One side rests while the other remains alert, monitoring the environment and controlling breathing. Others rely on strength in numbers. Mallard ducks often sleep in rows. The birds on the edges keep one eye open, watching for danger, while the birds in the middle sleep more deeply. Different species found different answers. But then researchers noticed something strange. Even when predators found sleeping prey that appeared completely vulnerable, they didn't always attack. And that made no sense, because from the predator's perspective, this should be the perfect opportunity. The prey isn't running, it isn't watching, it isn't fighting back. So why hesitate? Why walk away from what looks like the easiest meal imaginable? The answer begins with something called the startle response. Scientists studying predator behavior noticed something that didn't fit any of the models. Predators, even highly efficient ones, don't always attack sleeping prey when they find it. And the reason why turned out to be one of the most surprising discoveries in behavioral ecology. Let's talk about what a predator actually experiences when it finds a sleeping animal. It has all the advantages. The prey isn't moving, it can't run, it can't fight back effectively. The predator is close, it's hidden, and it has the element of complete surprise. But experienced wildlife researchers have documented case after case where predators approach sleeping animals and then hesitate, circle, sometimes even walk away. Why? The answer starts with something called the startle response. When a sleeping animal is disturbed, even slightly, a sound, a vibration, a change in air pressure, it doesn't wake up slowly. It doesn't open its eyes and stretch. It explodes into full alert in fractions of a second. Heart rate doubles. Adrenaline floods the bloodstream. Muscles prime for maximum effort before conscious thought has even registered what's happening. This is not an accident. This is one of the oldest survival mechanisms in the animal kingdom. The brain never fully sleeps. Even in the deepest stages of unconsciousness, a specific network of neurons stays active, constantly scanning for threat signals, ready to fire the alarm at the smallest trigger. Predators have learned this, not through reasoning, but through thousands of years of failed hunts. A sleeping wildebeest that explodes upright at the last second. A sleeping seal that twists and bites before the predator's jaws fully close. A sleeping deer that vanishes into the dark before the strike lands. Sleeping prey is not defenseless. It is differently armed, and the predator calculates this risk every single time. But then something strange happened in the research. Scientists studying lion predation in the Serengeti noticed a pattern that nobody could explain. Lions are the apex predator of the African savanna. They are powerful enough to take down Cape buffalo. They hunt in coordinated groups. They have no meaningful predator of their own. And yet lions, when observed approaching sleeping zebra herds at night, would frequently abandon the hunt before making contact. Not because the zebras woke up, not because the lions were spotted, but because of something in the way the herd was configured. The sleeping zebras weren't lying randomly. They were arranged in a specific pattern with certain individuals facing outward, certain positions always occupied by animals in lighter sleep stages. The herd, even unconscious, was running a collective defense system. The lions seemed to sense it. And this led researchers to a much bigger question. What about animals that don't have a herd? What about solitary prey? What about, and this is where it gets deeply uncomfortable, humans? Humans are, from a predator's perspective, one of the strangest sleeping animals on Earth. We sleep long, 7 to 9 hours of deep unconsciousness every night. We sleep in one consolidated block, unlike most mammals which sleep in short distributed bursts. We sleep on the ground or near it. We lose muscle tone so completely during REM sleep that our bodies are essentially paralyzed. And for most of human history, we slept outside, in the open, in the dark, on the African savanna surrounded by leopards, hyenas, lions, and wild dogs, all of whom were active precisely during the hours we were most vulnerable. Sleep researchers studying this paradox expected to find that early humans compensated with shorter, lighter sleep, staying partially alert, never going fully under. What they found instead was the opposite. Our ancestors slept deeply, more deeply in some ways than many other mammals, and they did it every night in environments crawling with things that could kill them. How did we survive? The answer had nothing to do with individual alertness. It had nothing to do with biological adaptations that kept us partially awake. It had everything to do with fire. Anthropologist David Samson at the University of Toronto spent years studying sleep patterns across primate species. He discovered something extraordinary. Humans sleep less than any other primate. Chimpanzees sleep around 9.5 hours. Baboons average more than 9. Gorillas push past 10. Humans average 7. But human sleep is far more efficient. We spend a dramatically higher proportion of our sleep time in REM, the deepest, most restorative, and also most paralyzing stage of sleep. We compress more biological recovery into fewer hours than any other primate on Earth. Why? Because our ancestors could afford to sleep deeply. Because they had fire. Fire changed everything about human nighttime vulnerability. It kept predators at a distance. Most large predators have an instinctive fear of open flame that overrides their hunting drive. It provided warmth, reducing the metabolic cost of sleep. It created a perimeter of light that eliminated the predator's most powerful advantage, darkness. And it allowed something else that no other animal had, social sleep. Humans slept in groups around the fire. Different individuals entered different stages of sleep at different times. Someone was always in a lighter sleep state, more responsive to sounds and disturbances. The group, organized around the fire, functioned as a collective alarm system, the same way the zebra herd did, but more sophisticated, more flexible, and capable of active response. The fire was the wall, the group was the sensor network. Together they turned the most dangerous hours into the safest ones. But here's the reveal that changes everything. In 2015, researcher Jerome published a study that had been watching 3 pre-industrial hunter-gatherer societies, the Hadza in Tanzania, the San in Namibia, and the Samana in Bolivia. All 3 groups still lived and slept in conditions close to those of our ancestors, and what Siegel found shattered decades of assumptions about human sleep and predator vulnerability. In all 3 groups, the members of each community almost never reached their deepest sleep simultaneously, without planning it, without scheduling it, without any conscious coordination. Individuals in the group would cycle through their sleep stages at slightly different times, which meant that at almost any given moment during the night, at least 1 or 2 people were in a lighter sleep stage, naturally more alert, more responsive, more likely to detect a disturbance and wake the group. The researchers calculated the probability that all members of a group would be in deep sleep simultaneously. It was nearly 0. The human sleep cycle, it turns out, is not just a biological recovery mechanism. It is a social defense system. Our brains evolved to desynchronize from each other during sleep, so that the group as a whole maintains a continuous low level of awareness, even when every individual is technically unconscious. We didn't survive the predators of the African savanna despite sleeping. We survived because of how we slept. Together, staggered, around fire, in the dark. So back to the original question. What happens when a predator finds you sleeping? If you are a zebra in a herd, the predator finds a collective system running beneath the surface of unconsciousness, and it calculates whether the risk is worth the reward. If you are a dolphin, the predator finds an animal that is never fully asleep at all. If you are a mallard duck on the end of the row, it finds one open eye staring directly at it in the dark. And if you are a human, the way humans evolved to sleep, the predator finds a ring of fire, a group of bodies at different depths of sleep, and the accumulated intelligence of a species that solved the impossible problem, not through individual strength, but through collective design. The most dangerous hours became the most human hours. The dark, which should have been the end of us, became the place where something entirely new was built: community, trust. The decision to close your eyes because the person next to you was watching, that decision, made every night for hundreds of thousands of years, is the reason you are here. And the next time you lie down in the dark and feel, somewhere underneath the modern comfort, a faint pull of unease, that ancient signal your brain still runs, checking the perimeter, listening for the thing that moves in the night, know that it never stopped protecting you. It never will.